Hello, everyone. So, as I have promised you on the seminar, I want now to record a video showing how we can improve our urban generator, which we got at the last session. So here I have my file, and you see that I have added some comments and explanations to some components we are using and some pipelines of how we connect them. And this will be basically my goal of today's video. I would try to make it as short as possible, so I might miss some explanations, but hopefully you will still understand it. And in case you won't, you can always just write me and ask for explanations. And also, the next session, we will have some time to dive into details of how this urban generator works, and you can ask any questions there as well. So today I would like to focus on these four topics. So first of them is preview of surroundings. The second is applying better offset to our buildings. Then parcel simplification and clustering of our grasshopper definition. I will start approaching these topics one by one. So let us start with preview of surroundings. And what I mean by that is that currently, in this file at least, I have my surrounding geometry turned off. So it means I do not see existing streets or existing buildings. I only see my generations. And of course, I can turn them on. So here are my inputs, which you received in the very beginning of our session yesterday. Oh, yeah, on the last Wednesday. And so when you turn on preview by right-clicking somewhere on the canvas with this component selected and selecting preview on, you can see that they overlap our current generation. So it becomes kind of unusable to have preview on because it disturbs from doing something with our generated forms. So one way to kind of exclude this area inside the plot outline, which we define by a polyline in Rhino, would be to apply trim with region. So trim with region is the component which I believe we have used on the last session as well. So this is how it looks like. It has three inputs: curve, region, and plane. We would only need curve and region. So curve is basically curve to trim, so what we want to trim, and region is what do we want to trim with, right? So in my case, region would be the boundary of our plot. And also notice that I turned on this green button here, which allows me to only show you a preview of what is currently selected in Rhino. So now I can select different variants, different components, and you see different items appearing in Rhino. So I need to connect my boundary to the region input of trim with the region. And as curves, first of all, I want to trim my streets, right? And now I can just copy the streets component a bit to the right. I do it by starting to drag this component and once clicking on the Alt button on the left of my keyboard. You can also just use Ctrl-C, Ctrl-V. So, and now I can either connect the inside output and then you'll get streets which are inside the outline, or I can use the outside. Of course, I want to use the outside output since I want streets inside the plot to disappear. And now you can see that even if I change my plot outline, streets are trimmed perfectly fine. And this is the result I want to get. So yes. And now I simply want to do the same for buildings, right? So I will copy these components, again by starting to drag them and clicking Alt once. And I will connect buildings instead of streets to this first curve input. And in the end, you can see that I now see all of my buildings there. And I need to rename the output, of course. It is not streets, but it should be called buildings instead. And now I can disable this preview mode and select things I want to hide. So now I can right click here and select preview off. And now, since the only data connected to streets and buildings which has been previewed on inside the Rhino viewport are these two components here, I only see my trimmed buildings and trimmed curves, trimmed streets. And this is exactly what I need. So now I can do whatever I want to my plot outline, and yeah, I get a proper preview. Another thing I might want to do is to change color of this preview, right? This is something you would use quite often, and I normally use the custom preview component for these reasons. So you can create the custom preview component, and we also need the color swatch. Color swatch, this one. Oh yeah, it is spelled color. So color swatch is a simple component which you can press on, and you will get this pretty nice way of specifying the color you want to get. So in my case, let me use something like blue, maybe darker blue, and I connect this color swatch to the material input of custom preview. And now I simply connect my buildings as geometry. You can see my buildings are now blue, so sometimes it might happen that preview of this component will overlap with preview of the next component, so I better turn off preview of these buildings, right? Because they are being shown through this custom preview currently. And I do the same for the streets. So I copy these components, and maybe I want to change color to something else. Maybe it might be dark blue, or it might be purple, whatever. So I don't care about the color that much. Yes, so this is it. And now I can maybe group them together, these components, and exclude these components from the previous group I had. To do this, I can select them, right-click inside the group, and select Remove from Group. So now I have separate inputs and separate separate pipeline for my generation. Yeah, I can also make wires not that visible here and not this distracting, so I can make them faint maybe. So I do this by right-clicking on the region input and selecting wire display faint. So it does not change the behavior, it just changes the how it all looks like. Okay, so 5 point is covered. Preview of surroundings is now set up. And the next point is better offset. So for using better offset, we will need to download the Clipper plugin. And I would say that you will use it really a lot of times in your studies with Grasshopper. So like you should really do it. But of course, if you don't like this plugin, you can find any other which suits your needs. But this is something I use regularly in my practice. So to download plugins in Rhino, there are multiple ways to do it, first of all. One way would be to go to the official website, which is called Food for Rhino, and download anything there. So you can just open Chrome and go into Food for Rhino. And maybe I don't need this. Oh yeah, okay. So Food for Rhino gives you access to many plugins, and you can scroll through them and download any of them. You'll just need to create an account here. But the more proper way to do it, and the more modern way actually, is to go into Rhino and use the official package manager which stores many of the plugins there. So to do this, you will need to go into Tools and find Package Manager. And when the window is opened, it takes a couple of seconds to load all plugins. But now you can just search anything you want. In our case, this will be the Clipper, and you need to download it. So I do not know exactly how Clipper 2 works, so I will probably continue to use the first version of this plugin, Clipper, without any version. So I have it installed, but if you don't, you need to select the latest version and click install. So after you click install, you would need to click install again. It downloads, it installs, and that's it. So I think you would need to restart your Rhino and Grasshopper to use it and to actually see it in Grasshopper, but you can experiment. So now I have it installed, and let me maybe find again some case where the usual offset didn't produce any meaningful results, like this one, right? So I think you remember that by some combination of lines and maybe combination of inputs like sizes of parcels I need, I ran into multiple problems, and yeah, most of these problems are actually caused by polyline offset because some forms are simply too complex for this plugin. Not plugin, but for this built-in component. And this is why we need to use the plugin. So I'm going into the buildings section of our script where I used offset curve. And as you can see, I have used it twice, right? So I took my parcels, offsetted them inwards, and then offsetted them inwards again. And you can see how the form breaks in this place, right? Now instead of this component, I want to use my new plugin I have downloaded. And to do it, you will need to write polyline offset in your Grasshopper, and you will get this plugin here. Polyline offset offsets a polyline curve using Clipper. I create this plugin. I create this component, and now I can simply connect my partial curves to the polylines input. And the second input, which is super important, is the distance, of course. So let me create a slider from 0 to 20 meters, and I will add 20.00. And let us check how it works. So now I have my polyline offset selected, and I increase the distance, and you see how like my lines do not only offset in one direction, they actually are being offsetted in two different directions. So we get the outer contour and the inner contour. And this is one peculiarity of how this plugin works. And but we can still use it, and it actually produces very nice results, as you can see, and it does not break in these cases, for example, when the curve starts to be too small to produce any meaningful inward offset. So I would need to connect my original input, which is called offset from parcel, instead of my distance input. And now I have two outputs of this component, contour and holes. And I would simply need holes because contour is the outer edge and holes are what has been offsetted inwards. So I need holes. I will create a new data container to check what is there. And yes, indeed, it is exactly what I need. And now you can even compare how these two components work. And you see that, polyline offset has advantage of not breaking into in complex cases. So I can now create another polyline offset. because as you remember, I needed to apply another offset here as well in my script. So I will connect this hole's output again to the polyline's input of the second polyline offset component and connect the distance I have here uh, to the distance input. And also notice that I do not invert my distance. So I do not pass minus 5.4 here. This is because polyline offset only works with positive distances and it cannot work with negative distances. It will simply break if you connect negative distance, or not break, but it will not produce any results. So I do not use those. And now in my output, I again need only the holes, right? So I can copy this data container, connect to the holes, because I do not need contours in this case. And now I have these two data streams, which I need to create buildings, right? So if I select both of them at the same time, you can see that they actually represent the outlines of my buildings. So let me connect them here to this merge component instead of original data streams. So I connect this one to the first data stream and this one as the second one. I do not need offset curves anymore. I can remove them. And now I can paste this new part of my script here. And as you can see, I do not have enough space to do it, so I can extend my canvas a little bit. I press Alt, I hold it, and with my left mouse button, I can now extend canvas to the right and paste these new components here. Maybe I can also change the position of a couple of elements a bit so that it looks a bit nicer. And yeah, I think that's it. So now we have in the end our curves for buildings. And yeah, you can see that the merge component does not put these two data streams in the same branch, because apparently they have different path, like different address, right? So I need to flatten the output of this merge component so that the next component, which is called boundary surface, and which basically tries to find all enclosed surfaces in input curves, so that it can work with all curves at the same time without differentiation between different branches, and so that it can find building outlines properly. And you can see, I can save the file, that now it works much better than it used to work before. And I can change my position of my streets. I can also change size of my parcels, right? So the wished X size and Y size. And you can see that basically it always produces some results, right? So unless the space is not enough to actually put any closed blocks there, right? But now we always have some results, and this is great. So the second point is also covered. The next one is called parcel simplification. And this one, it is quite important. Maybe one example which you can see right now is here. So due to some operations we run on plots and parcels, we got some really tiny triangular building, which is probably not what we want to have, right? Because we will not be able to work with this form later, and we cannot consider it to be a building. So let me maybe troubleshoot it and try to find the place where it happens, right? So to do it, I would usually go from left to right of my script with this mode selected, this selection preview, I would call it. So I would go from left to right and check where the data starts getting incorrect. So I have my plot, I break it, like I have my boundary, I break it into small plots, and still, like, I do not see anything bad there, so it was fine. Then I go into the parcellation. We generate some bounding boxes. I scroll to the right. We apply some trim with region. Then we do surface split. And then we go into buildings. So buildings still get proper inputs here. And then I go even more to the right, and I see that holes also have some proper outputs. And another one, So you can see now that somewhere here I have like this polyline offset generates some weird output shape, right? And in this particular case, actually it happens not due to the reason I thought. So in this case, it just so happens that let me select the input of this polyline offset and the generated output. And let me now move the building depth to 0, right? So now polyline offset is basically not doing anything. And now let me start to increase the size. And you see how it applies offset in both directions, right? So it tries to offset all curves inwards, but also outwards. And starting from some point, and for me it is 13.0, you see how the outer offset of two curves, which are situated close to each other, start to touch, right? And if I move it a bit higher, they will touch, and they will basically be united into one form. But this one small triangle was not united because it was, because you see how this offset works here. So it basically generates a small chamfer on this corner. So to somehow avoid these small things building up, you can apply the data tree structure actually. And let us try to do it, and let us check whether it will help. So now polyline offset is applied to all curves at the same time, right? So you can definitely see how it kind of observes which curves are now offsetted too close to each other, and it welds them together, right? So it tries to create this unified offset for all curves. And you can also look at it here, right? So we apply offset, and then offsets of two different curves, they merge together. If we want to avoid this behavior, and if we simply want polyline offset to be applied to each curve individually, right? And in this case, of course, we will only get one whole output out of each curve. So we will not get any holes which appear somewhere in between different parcels. So to do this, we can explicitly tell polyline offset that we are not working with 8 polyline curves which are stored as a list, but we are working with a data tree of polyline curves. Because now if we just isolate each curve into a separate branch, polyline offset will run 8 times for each curve individually without even knowing about other curves. So let us try to do it. I right-click on the polylines input of my polyline offset, select graft, and now you can see how the form also changed. And now my output is of course also a tree, because now it has a tree of 8 branches as input, so it also generated a tree of 8 branches as the output. But I can simply apply flatten to the outputs of this polyline offset. Now let me go back to the slider and check the behavior. So we see now that offset of these curves do not merge together. So I see that they simply start to overlap, but they are not united to one shape. Let me now go to the building's output and check whether it now looks better or not. Yes, indeed. So I do not get any weird shapes here, which are caused by polyline offset, and this is very nice. But what I wanted to show you was actually something different, And let me try to find such cases again. So sometimes if you have an unusual form, like maybe I will do something like this. No, it still works somehow. Yes. Okay, now I got it. So sometimes if your original boundary was of a strange form and maybe it included some like really small corners, uh, the building shapes which are generated may also look quite unusual and not that professional and usable, I would say. So there is one way to avoid it, and we can simply do it by cutting off these unused corners. Let me maybe draw it for illustration. So imagine we have this plot, and for some reason it has this um, very small corner here, right? And we somehow need to get rid of it, and maybe it just looks a bit too strange. I would maybe create a simple corner like this. So we need to get rid of this small corner because otherwise our geometry might also be corrupted. And a very easy way to do it is to explode this curve into segments, right? So I explode it into all linear segments, and this will be segment 1, segment 2, 3, 4, here 5, 6, and 7, right? So I will just break it down into smaller parts which constitute this polyline. And now I want to extend them. So I want each of them to be extended in both directions. Let me maybe remove these green lines I just created. I don't actually need them. So I want these lines to be extended like this, maybe 10 or 15 meters in both directions. And you will now see why I want to do it. So if you extend these lines here, you'll see that this small corner is actually cut off completely by the lines I'm having here. So if you just extend them and somehow cut through this polyline with these lines, you will get the behavior you actually want to achieve. And the same will be applied to all smaller corners which you will find on your in your yeah in your inputs. So for instance, this example, again, if you apply all possible extensions of these curves, you will see how they start to break this shape into multiple and more manageable parcels. So in this case, this original shape will be broken down into parcel 1, parcel 2, which will be super tiny, and parcel 3. And of course, in case it happens that this weird corner is somewhere in the middle, we do not want to lose any like any half of them, right? So we actually want to save both of these parcels, or maybe even all three of them. Let me just draw it a bit more precise. Yes. So this line and this line. We will also break this parcel into 3 individual parcels, 1, 2, and 3. So we do not want to lose any of this space. We just want to break it down into multiple things. And in case some of them are too small, like maybe this one or this one here, we also do not want to generate anything there. So we want to get rid of these small parcels where we are not able to generate any buildings. And maybe even this one here is also too small, and maybe it can also be just avoided completely. And let me show you how we can generate this kind of behavior in our script. So first of all, we need to find the place where we will do it. So from my perspective, I think it should happen somewhere before parcels. So when we just broke our initial plot into like street blocks, right? And you already see that I have some weird corners here. So this is number 1. This is number 2, probably. This one is a smaller one, number 3. And this is number 4, right? So I already have these weird corners here. So maybe I can do it here, or another option for me would be to apply it after my parcellation script. So to apply it on these volumes, which are already split into individual parcels. I think in my case it does not actually matter that much, so I will probably apply it after parcels. But of course, you can run some tests and maybe you come to some conclusions which yeah, can lead you to the better place of where to insert this logic. I will work with these parcels. Let me maybe create a copy of these parcels so that I can work a little bit like isolated from my original script. And now, yeah, I simply want to do what I already described. I want to explode my outlines into individual segments. And to do this, I apply explode component. I connect my parcels to the curve input. And now you can see that two outputs are segments and vertices. Vertices are like points of my parcels, and segments are individual segments. I would need to take my segments and to extend them in both directions. To do this, I will use the extend curve component, which takes curves. In my case, I will connect segments to this curve input. And I also need to specify start length of extension and the end. So the starting and the ending extension of curves. So start is like the distance on which I want to extend my curve in the beginning of this curve, and end at the other end, right? I will create a slider, maybe from 0 to, let's say, 20 meters, and I will connect it to both start and end, like this. Now, let me select extend curve to see what happens if I move the slider, and I will move it from 0 all the way to 20. And you can see how all my segments are now being extended. And you can also see how some of them start to cut off the small corners, like in this case. But in some other cases, like the one I initially wanted to show you, like the length is probably not enough to cut off this corner, right? So this was the original form, and this is what happens if I extend all the segments. So of course I can just change my slider size. I can go into edit and move the maximum to maybe 40 meters. And now I just extend it a bit more until, until my test case actually works out and I get the result I need. So in my case, this will be something about maybe 30 meters, maybe 35 meters of extension. And now I need to apply this division, right? So I need to cut my original parcels with these lines. And if you remember how we did it before, like somewhere in the very beginning when we generate plots, we use the surface split component. So it takes surface and curves, and it splits surface with the curves. I will use exactly the same approach. So I'm using surface split component, which takes surfaces and curves. Now, since we are dealing with multiple plots or parcels at the same time, and also multiple sets of segments, we somehow need to understand the data tree structure in this case, right? So we will have to deal with data tree structure more and more often now. So what I want to do is I want to get this isolation of operations inside each parcel. So I do not want parcel 1 to be anyhow affected by segments of parcel 2, because otherwise it might happen that like this line which is somewhere here outside the original parcel 1 will just shoot here, and it will cut some part of the parcel 1. And I do not want to get it. I want to work with each parcel individually. So it probably means that I need to have 8 branches in my case, right? Or let me actually check how many parcels I have. Yes, I have 8 parcels. So I do not want, let's say, this parcel to affect this one. I simply want to have this isolation. So I probably need to work in 8 different branches. So when I connect my parcels as surfaces in the surface split component, I need to specify that instead of working with a list of 8 items, I want to work with a data tree of 8 branches. So I right click it and select graft. So I'm grafting the surface input. And let me now check, yeah, you can check the surface input now, how it looks like, and you can clearly see these 8 branches. Let me do the same, let me check what is the output structure of this extend curve component. So I can point on the curve, and indeed, I see that I have 8 branches, and each of them has either 6 or 9, or again 6 or 5, and so on, segments. So that's wonderful, meaning that for each branch, I'm working with one surface, right? So one parcel, and all segments which were generated by this parcel, because they will end up in the same number of branch, of course. And so my split surface works like magic, you can say, and I definitely get the results I wanted to get. So all my corners are now cut off, and this one as well. So this is great. And now we somehow need to add the last step, which is to find out which of the parcels are too small to generate any buildings, right? Because if we simply connect this output to the parcels input of the buildings, I can do it. And also you see that the output is a data tree. I do not want to work with data tree anymore, so I can flatten it. You can see that I still get some small triangular buildings here, and I simply do not want to have it. So if I have cut off something, I do not want to get any buildings there. To do this, we can apply a pretty often used pattern in Grasshopper, which is called filtering. So we want to filter this data stream, which now in my case contains 13 elements. I want to filter all the smallest one. I want to filter all plots which have too little area. And we can do it using the cal pattern component. So cal pattern component is very important. You definitely have to remember it. It will remove elements in a list using a repeating bit mask, right? I will explain what that means a bit later. So I connect my fragments to the list input of this cal pattern, and now we need to specify the pattern itself, the pattern as well. To do this, we can we somehow need to create a list of true and false values, one value for one parcel, which will tell cal pattern whether we want to see this element in the output or not. So we want to say yes, yes, no, yes, and so on. To sort based on the area, I would need to do it with the area component. The area component takes any 2D geometry, like curves or surfaces in this case. It doesn't matter that much now. and it gives you the center point and the area of this geometry. So now I can use the component which is called larger than, or you can also simply type this larger sign, and you can now compare one number with the first number with the second number. So in my case, I want to compare area of each individual parcel with some threshold number. I will just enter a new slider and I will give it a range from 0 to maybe 30,000 square meters. So this will be my threshold. And I can now connect it to the second number, and we almost have everything set up. So the larger than, since it compares one number with another number, it has this output, which is like, it has two outputs actually. We will only need the first one. And you can see in this description that it is true if A is larger than B. That's that simple. Let me connect the panel to it so that I can convince you that it is indeed working as it promises. So now I can just turn on preview of these parcels, and I can change my slider and see how the values are changing as well. So you see that after I change this value to something like 500 or maybe 1000, some parcels already break this, do not pass this test, and they are not larger than this number. So the larger than component returns false. This is great because this kind of output, this structure of output is exactly what the call pattern needs. So I now connect this larger than output to the call pattern, and you can see with your own eyes how this great thing works. So if I move the slider all the way down to 0, nothing changes because of course all of my parcels are at least like 0 or 1 square meter large. And then I can move it higher, and after 890 you see that all of my smaller parcels disappear completely. So I do not get any weird corners, and yeah, I can go even higher, and I can also get rid of these like other parcels which are not larger than this number. And of course, I do not want to do it. I only want to get rid of small corners. So I will maybe set it to 500 square meters and check what happens. I think it looks fine. I do not see any buggy shapes here. So I think this is what I will use. And now I need to connect output of this call pattern with the input of my buildings group. And let me check the output. Let me check everything that I have in the end. So you can clearly see that now it all functions very well, and I do not see any problems appearing. So this building might be too small, right? And of course, we can also filter out parcels which do not allow to build a closed block topology with a proper courtyard. You can definitely do it. Okay, maybe this parcel is not large enough, right? So let me go back. This is always a testing process that you have to go back and change something. So my original parcel had this shape. And now you can see also a very good example of how surface split works. So in this case, this line is just being extended here, and now it is split in two parts. And after my call pattern component, we also get rid of this smaller triangle. But what I'm actually thinking is that this triangle here is also it doesn't have sufficient space to build a house there. So let me just increase my threshold to something like 2000. And yeah, otherwise it looks fine. So let me again jump to the outputs. Yeah, well, I think it is proper. It is a correct decision now to not build anything here. And I can continue. Okay, you see that I have some kind of a bug. Again, I can just go back and check what has led to this bug. So here, before the buildings, I already see that I do not get any parcel here, or I get some small, very small triangle. And also something at the left here is probably broken. I do not understand exactly what caused these lines. So parcels, let me go back. Beginning of parcellation. Okay, I already have some problems here with this small triangle. Let me go back to the plots. So this is the plot the plot boundary I already had, and streets. So this is what I get after I apply surface split. And then, okay, now I have identified this space, like this space on my canvas where some bug happens, right? So surface split still looks good. And then the output of of offset curve already has this weird broken space. So the solution would be to simply remove this offset curve and use polyline offset. So polyline offset, again, part of the Clipper library. It will provide better results. That's my hope. And I simply need to connect fragments to the polylines and my original offset distance to the distance. As you remember, it applies offset in both directions, but I only need holes in this case, and I connect holes to my plot's output. I can now remove my curve offset, remove some other unused things, and maybe turn off preview. And now let me jump to the back, to the end of my algorithm again to check the outputs. And it looks nice now. So I do not spot any mistakes here. You can continue experimenting like this, and maybe you can spot something like this, right? So in some cases, we still have weird buildings, and it probably means that I need to go to this extend curve and maybe change 30 meters to something larger. Otherwise, you can see that my curve, it does not go all the way through the plot, and so it does not slice it. So maybe in this case, I need to go all the way up to 40 meters. Yeah, let me check the output. This is fine, but also you can see that I got this small corner cut off here due to some reasons. I cannot exactly tell you why. So this is, okay. So this was the parcel I had, right? And you see that the plot out the, what was it? The polyline offset has generated this small chamfer on this corner. So this is something I want to avoid, I guess, because otherwise, if I extend it, it cuts both corners off, as you can see. And it is not that important, but if you also want to avoid it, you can go back to the polyline offset, which we just added in the beginning of our script. And we can now take a look at these two inputs, closed fillet and open fillet. So closed is applied where where the line does not break. So in our case, we will only need to change the closed fillet because we always have closed curves, and open fillet is applied at places where the line has its beginning or the end. So for us, it does not apply at all because we only have closed parcels here. So closed fillet has three different inputs, round, square, or meter. And let's just zoom in at this place and check how they affect the outputs. So I will right click on this closed fillet, and sometimes especially some components which are included in plugins have different special fields here, I would say. So in this case, if you right click on the closed fillet, you will see round, square, and meter checkboxes. If I select round, it does not, no, it changed. So yeah, you can see that I got this rounded corners now, and on the outside as well. So you will see it everywhere. Yeah, and we can check the results, of course, but I will tell you that this is not what we want to get. Because yeah, you see how it breaks geometry in some cases pretty significantly, and we can of course try to find the reason for it. And yeah, probably the reason is this surface split, because like when we create a circular corner here, it does not mean that it is completely round. It means that it consists out of many small small segments, and if we prolong each of them, it means that we will come up with a pretty weird result. So let me go back to the polyline offset and change it from round to meter. And now you can see that it got a bit better, right? It actually got very better. It got very good. So I do not get any cut off corners. And this is fine for me. I will leave it like this. Let me just check the outputs again. Okay, yeah, you can see I still got some problems. Yeah, it looks very strange that I have it. So maybe I will still need to tweak down this extend curve to maybe something below 30, because otherwise I think two big chunks of my plots are now being cut off. So now I think I will leave it by 30 or 29 or something like that. Okay. Yeah, maybe I can increase this threshold for my cal pattern all the way to 2,800 or maybe even 3,000. I think I would say 3,000, because now I want this vertical plot here to disappear, because I do not want to see it. So 3,000, not 100. Okay, look good. I can now create a new group, Control G. I can now move this this part a bit to the right, and paste this group into my Parcel group. So I select all elements here. I right-click in the Parcel group and select Add to Group. I can also write a small scribble here to to just leave a comment on what I'm doing here. So extending parcel segments, cutting off small corners, filtering out small parcels. That's it. I will maybe change the size to 15 points, because this is what I usually used for such kind of comments. I can also change color of this group. So I can select it, right click it, and change the color to white maybe. I like how white on blue looks like. Okay, I think I'm basically ready with all changes. And the last thing I wanted to show you after I save my file was clustering. So this is something which we can do pretty quickly. Basically, the idea of clustering is that when your definition grows and it gets pretty large and a bit chunky, and it gets pretty hard to navigate through it, it is always a good idea to cluster things in small kind of containers or clusters. And to do this, you would simply select, let's say, the whole parcel group, and you can right-click it and click cluster. So before I do it, I want to do one little thing. I want to deselect these slider inputs because I do not want them to be stored inside my cluster. I want them to be outside, so I can move them a bit to the left. I can also actually dissolve this group by selecting it and clicking delete, but it is not that important. I simply want to select everything except for the sliders. So now I right click, select cluster, and you can see how my whole chunk of parcellation got got squeezed into this one small cluster. And also, if you point on it, you see the insides of this cluster. You can double click it, check what happens here, right? You can, again, you can save this this cluster by clicking on this box icon and selecting save. And until you save it, you will not get any like changed behavior in your original file, of course. So now the only thing which bothers me is that I have three different outputs. Let me check what are they, because I actually thought I will only get one in output. So I have one parcel, and this one is correct. And okay, I was connecting my output plots and parcels from somewhere inside this group. So I will press Ctrl Z until my cluster dissolves back into this group. And now I need to reconnect these outputs here. I do not want to, like, I simply want to connect them directly to the plots output here. And this parcel is also, it should be connected with the very, with these parcels maybe. So with the very final parts of the parcellation. Okay, this is great. I move it back to the end of my file. And now again, I can select all components which have something to do with parcellation, right click them, or right click somewhere on the canvas and select cluster. Nice, this is much better. So I now have only one output, and you can see that all inputs are automatically connected. I can now maybe store them a bit closer to this cluster and move this part a bit to the left. Like this, I guess. Yes, this looks very nice. I can now again create a new group, maybe copy this scribble and rename it to parcellation. Is it parcellation? Parcellation, doesn't matter that much. Parcel, probably parcellation. And edit the group. Yeah, it was the last topic for today. You can see that we have achieved quite some things here, and yeah, I will need to turn off some previews of some components now, and this is what we get in the end. So I think you can definitely understand why I wanted to record this video, because you can see now some other ways of how we can work with Grasshopper and how we can improve on something we created here. Also, I hope you got a small glimpse in how you can test your own components and find these proper values and ranges for some filters you want to create or for some pipelines you want to use. And yeah, hopefully we will be able to do some Grasshopper stuff very soon. but I think we will meet with you in 2 weeks, right? So it will be this 13th of November instead of 6th, because on 6th, some of you will have the excursion week. And yeah, we will do some more interactive things there. Until then, please introduce the same changes I did to my file to your files. And I will soon send you the link to assignment folder on OTP, I guess, where you can just submit your files and I will take a look at them. Yeah, probably without giving any comments because that's too many of you. So I will reserve this my time for giving out comments on your files for interactive sessions and maybe for some other assignments. But if you have questions, of course, do not hesitate to just write me and maybe send screenshots or your file definitions. I hope I will be able to take a look at them and reply to you soon. So thank you for watching this video, and I hope you will have a great time and see you again. Bye bye.